everybody, and welcome to session 3 of Glow Your Own. I'm in a slightly different place than usual today, so we have a church concert that's celebrating astronomy and Polish astronomer called Hevelius, who in I think 1647 drew a really accurate map of the moon, which is on display in the Bodleian Library today and tomorrow. And we have a concert that is a contemplation on the moon with a Polish pianist called Marcin Masecki, who's going to be doing something really cool tonight. But before that, we have Glow Your Own. I'm just explaining why I'm in a funny place. And the great thing about this church is that it has a really nice roof with some stars on it. So hopefully I can show you what this roof looks like here. So this is a church in the centre of Oxford. For all of you people who aren't in Oxford, this is a bit of what Oxford looks like. This is the University Church, a really nice venue. And I'm going to go into the back of the space and help with some coding while we set up for the concert. But I thought if we're doing this tonight, it'd be quite fun to show people a little bit of Oxford. So today we're going to be doing a bit of coding that allows us to control the Arduino with a button. So I'm going to introduce Sophie and Sarah and Vicky, who are going to be doing the regular roles. So maybe if everyone could say hi, we can get everyone on to say a quick hello from the team. Great.
Hi everyone, it's lovely to see you all.
Hi.
Hello.
Lovely to be back.
Yeah, so as usual, please log into Tinkercad with your codes and get ready for some coding.
I think we're ready for some coding and making.
Great. All right then, I'll pass over.
Fantastic, thank you, Dane. Right, hello everybody. I'm just going to make it so that you can just see me for now. All right, so like Dane said, today we are going to be using buttons, which is really, really helpful because if you are like Vicky and I, you don't just want a light to go on, you want to be able to control that light, to be able to turn it on when you want. And the really cool thing about Arduinos is not only can it send instructions out, but it can also find out about the world around it. So it can find out if a button is pressed. Later on, we'll be finding out how dark it is and using that to control our circuit. And it's got all kinds of other things as well, other sensors that we might not use in Glow Your Own, but you can experiment with later on as you explore more with Arduinos as you go through. So I'm just going to share my screen so that we can get started. We're going to start as we normally do with Tinkercad. We're going to create our circuit and our code and Tinkercad, and then we will make it into a real physical circuit so we can turn a light on and off with our button. Okay. All right, so you're all pros at this now. So I've gone to Tinkercad, and the link to the classroom is in the chat. I'm going to click join with login code, and then all of our login codes have the same format. So mine is 2025.glow. Everyone says that, and then dot, and then mine is 001. But you all have different numbers at the end. If you've forgotten yours, then you can pop a thing in the chat, and Sarah or Vicky can let you know what your code is, and then we click go to my class. Then it thinks about it for a while. And now we are in Tinkercad. We're still doing Tinktober, so it's still Halloweeny and spooky. And you can see here are the circuits that we have created together over the past couple of weeks. So I'm going to create a brand new circuit just so that we all remember what we're doing and things. But if you prefer, you can just use the circuit that you did last time and then add to it, because we're going to create the same sort of circuit, but then add our button to it. All right, so I'm going to create a new circuit up here. So I do create and then buttons. And then the first thing I'm going to do, because Dane will tell me off if I don't, is I'm going to call it something sensible that I will remember what we did there. So I'm going to call it GYOwn 3, because it's the third session. Buttons. Okay. So the first part of our circuit we'll probably do quite quickly because it's the same as the circuits that we've created before. So we're going to have a light that we can control on and off. If it does go too quickly though, don't worry, because it's all on your worksheet and it's all being recorded. So you can always watch us back, pause us, laugh at the funny faces that we're pulling when we're paused, and then carry on however, at whatever speed you want. So I'm going to start by bringing out my Arduino, because that is the core part, is the heart of all of the circuits that we create. And then, so this is going to control everything that we do. Then I'm going to get my breadboard, and I know that you've got your physical breadboards with you already, which is great, and stick that out here. Do you have any questions or anything in the chat? You can pop them in the chat, and Sarah or Vicky can have a look and do their best to help, or we can interrupt and go over something else if lots of people are getting confused by something. All right, so we've got our circuit. We're going to turn a light on, but we're going to control it with a button. But the first bit we need to do is to get the light. So I'm going to get my light, my LED. I'm going to try anyway, pull it over. I think I'm going to have a different color light today, just for fun. I think I'm going to have a green light. There we go. So remember, you can change the color of your light by clicking on it and then changing whichever color you want. Now I want to be able to send instructions out to my light, and so I'm going to do that by using a wire to connect my light to my Arduino, so I can send instructions out. So I'm going to go from my Arduino here, pin 4, and then I'm going to connect that up to my light like that. And remember, you can make nice, neat wires, partly because it makes me happy, but also because it makes it easier to spot if there's anything wrong. If you've got your nice, neat wires, it's much easier to spot them to spot where something isn't connected properly. All right, so next step, we're going to connect the light to a resistor, so make sure it doesn't get too much power. So I'm going to get this resistor over here and then click there. So remember, if we trace our circuit, we're going from the Arduino through the wire to the breadboard, through the LED, back to the breadboard, and then to the resistor. Now I'm going to change my resistance to a lower value. So I'm going to say it, instead of 1,000 ohms or 1 kilo ohm, I'm going to call it 220 ohms, like that. And then last step, and then we'll take a breath to make sure everyone is caught up. We're going to go from the resistor back through the breadboard and then back to our Arduino to the ground, or GND. I'm going to go from the ground and like that. Oh, and then I'm going to make it nice and neat. And what I'm going to do is I'm going to change my wire to a brown wire because it's going to the earth. Now, remember, the color of the wire doesn't make any difference physically, but it can make it easier for you to tell what different things are doing. So in my rules, brown goes to the earth because the earth is brown. And if I'm sending instructions out, I'm going to make those wires green. Okay, and then we're going to have 2 whole new colors later on in just a minute. So give me a thumbs up if you have this nice little circuit. We've done this circuit before. Brilliant, some great thumbs up. So let me know if you've got this all sorted. Good job. All right. So we did do that before. Don't worry if you're not there yet though, because we are recording this. So you can always double check what we said in the recording. Now the next bit is the fun bit, because we are going to use a button to control our circuit. I love it when we start to use the Arduino to sense the world around you. And actually at the lab where Vicky and I work, we use Arduinos in lots of our labs to monitor the environment, to make sure that the environment is right for the experiments that we're running. All right, so today we are going to use our button. We're going to use a button to control our light. Now, there are different types of buttons that you can use. What we're going to use, because I think it should be in everybody's kit, we're going to use a push button, which you can see right up here next to the LED. So if I pull that over, I'm going to put it onto my breadboard. Now, buttons should go over the middle kind of gap that's in your breadboard. So 2 of the little legs should connect to the breadboard on the same side as the LED, and 2 should connect on the side where there isn't anything, like this. So it kind of acts as a bridge between those 2 different sides. I'm just going to zoom in a tiny bit so maybe you can see a bit better. All right, and now buttons also need a resistor to make sure they don't get too much power. So we're going to put one of those in first, and I'm going to connect it. So I'm going to get my resistor and I'm going to connect it from one leg back to this blue line. So the same blue line that the other resistor is on, that is going to connect to the resistor to my button. Okay. And it can stay as 1 kilo ohm. We want a little bit of a stronger resistor for a button than we do for a nice bright light. Okay, so it is now connected to the Arduino, to the ground, because it can go through this wire from the ground to the blue line, which you can see here, and then to the resistor, and then to the LED. Not the LED, sorry, the button. But I want to get instructions back from the button. I want the Arduino to know whether or not the button has been pushed. That means I need to connect another wire from my button to my Arduino. So that wire, I'm going to go from here, so on the same column as the button and the resistor. So between those 2, I'm going to click there. That's where my wire is going to start. I'm going to pull it all the way over here to make it nice and neat. And then I'm going to put it down to pin 2. Okay. Now I'm going to change my wire color, like I said we would, to a yellow wire. And that's going to be my code for I'm getting information back from the world. So that's information that goes from the outside world to the Arduino. Okay, so we've got nearly all of the components for this next part of it. We just have 2 more bits to go. So I'm just going to have a pause and make sure, see where you all are. So give me a thumbs up or an emoji or something if you are ready for the next step, or if we should pause for a little minute. A little minute? Yeah, pause for a little minute so that everyone can catch up. All right, so I can see that some of you are already there. Brilliant job. So yeah, just give us a thumbs up if you are great. So we've got, all right, we'll give it just a second. So you can see that now our Arduino is connected to our button in 2 ways. It goes to the ground through the resistor and the breadboard down here. And it goes up here all the way to the button through this yellow wire that's going to take information from the outside world. Now, just while we're pausing for a minute to make sure that everybody is ready for the next step, you'll see that some of these numbers have little twiddly bits next to them. Mostly they work the same way, but as the numbers without the little twiddly bits. But For something like this, for the circuits that we're going to be doing, we would always recommend using one of the numbers, one of the holes that doesn't have a twiddly bit next to it. So I'm using 2 and 4, which are just 2 and 4, because it just avoids some potential complications. Brilliant. All right, let's do the next step. Now, buttons are a bit special. They're a bit different because they needed some extra power, but that's okay because the Arduino can do that. We can either get the power from the computer, or maybe at the end we will show you how to connect a battery to your Arduino as well. So you can see down here, I'm just going to zoom in a little bit so you can see more clearly. On the other side of the Arduino that we haven't gone to yet, you'll see some little pins that say 3.3 volts and 5 volts. Okay, and so we want to get some of that power and take it to the button. All right, so we're going to do that in 2 steps. So we're going to go from the 5 volt pin on the Arduino down here at the bottom, and we're going to go all the way down, around, and back up to the breadboard, not to the blue line where the resistors are, but to the red line where you can see a plus. I'm going to make my wire nice and neat, and then I'm going to make it red because I'm getting power. And that always, and red feels like a powerful color to get all of that nice power from. So I've got some power to my breadboard, but that isn't connected to the button yet. So I've just got one more wire where I'm going to go from this red line. So you can see if I hover over the red line, you can see all of the connections on the breadboard that are circled in green. I'm going to go from there to the other leg of the button up here, like that. So now the button is connected to the power as well. So it's going to get all of that nice power. We'll be able to work. So we normally use the 5 volt power for buttons like this one. Yeah, you can use different values of power. Okay, so you're ready to do some coding? That's always the best bit. Don't worry if you're late. Just like always, we have been recording this, so you can always watch the recording and follow along the recording, and you can also see the code and instructions on the worksheet that Dane sent out earlier today. Okay, so we've got our lovely circuit, and now I'm going to do some coding. Give me a thumbs up if you're ready for the coding while I take a sip of water. Great. Oh, a knife and fork. Brilliant. Good job, everyone. All right, so remember the code is up here on the right of our screen. So I'm going to pull that over, and then I'm just going to make it a bit bigger because I like to be able to see clearly what I'm doing. Okay. Now, just like always, Tinkercad is like, oh, I know. Do you want to do this code? We don't want to do that code. We're going to delete the code that Tinkercad gives us. So I'm going to pull it over here, delete it, and get that satisfying deletion noise. And then what we're going to do is we're going to use a new type of coding, which you might have done in Scratch before. We're going to use a new command called if. Which is really, really cool. So to start with, we're going to do the same sort of code that we did before. So we're going to go to control, and we're going to get the forever loop because we want this to happen forever and ever and ever. So I'm going to do that. But then instead of putting in straight something about turning on my light, I'm going to go down here in control, and you'll see that there are these 2 blocks called if. There's just one that just says if and then, and one that says if, then, else. So we are going to get the block that says if, then, else, which is this one down here. It's got 3 little things in it. We're going to pop it into our forever loop. I'm going to zoom in a bit so that it's easier for you to see. Now, if blocks are incredibly useful, we use them all the time in all kinds of coding. So it's basically every time you have an if block, you ask the computer or the Arduino a question. So the question we're going to ask is, we're going to say, Arduino, is the button pushed? And if the button is pushed, the Arduino will say, yep, it's pushed. And then we'll say, okay, we'll do whatever we tell you to do in this part. And if it's not pushed, it does a different command. So it will do whatever is in this part down here, whichever blocks and whichever commands we put there. So we use this, it's really important. We use it all the time. So like I said earlier, we use Arduinos in our lab to measure to monitor the environment. So we measure the temperature and the light levels and things like that. So sometimes we might have an if loop that says, if the temperature is above a certain amount, so it's above 30 degrees, we're going to make an alarm go off because that means our experiment's going to stop working. All right, so let's put our question in here. So this little sort of hexagon shape is where we're going to put our question, and that is going to be a maths thing. Tinkercad is American, and so it's called math in American, but I'm going to say maths. So you click on the maths and you can look at these different conditions, okay? And so it can do lots of different things, and we'll use some of them later on as we go through. But the one that I want to look at today is the second one down. So this hexagon one, I'm going to pull this out and I'm going to pop it into that little hole in my if statement. And this is the question. So this allows us to compare two different numbers. So at the moment, it's comparing the number 1 with the number 1. And it says if 1 is less than, that's what this triangle means, 1. Sorry, I just saw in the chat that that somebody knows a bit about blocks, and that made me laugh because it's a fun coding joke. Brilliant. It's a great joke. I love it. All right, so we've got this comparison block here. And what we want to do is we want to know, has the button been pushed? Now, if the button has been pushed, its value will be 1. And if it's not, its value will be 0. So if you go over here to the input section, the purple one, you can read in the different values of the things that the pins are connected to. So we want to read the digital pin here. So that's the very top one. We're going to pop that in that little circle there. So we're going to read digital pin. So we're going to find the value of a pin. At the moment, it says pin 0, but our button isn't connected to pin 0. It's connected to pin 2. So I'm going to change that to pin 2. Okay. So it's going to find out that value. And if it is equal to 1, then I want to turn the light on. And if it's not equal to 1, I want the light to be off. So I changed this symbol here from a less than, which is this little arrow going to the left, to an equal sign like this. So that says if pin 2, our button, is equal to 1, so if the button is pushed, then it will do whatever in here. And then we just have to do our commands. So are we ready to decide on our commands to put those in for the last couple of blocks? Give me a thumbs up if you're ready for the last couple of bits of the code. Great job, everyone. Fantastic. All right. Brilliant. Okay. So the commands, the blocks that we're going to put in here are our outputs. So we're going to send instructions out through our green instruction wire to our LED, to the output here. And this bit is just the same that we've used before. So I'm going to send an instruction. I'm going to send an instruction to pin 4 because that's where my LED is connected. So if my button is pushed, I want pin 4, my light, to be high or on. But if it is not pushed, then I want that to be off. Oh, so I'm going to get another one, set pin 4. I'm going to send an instruction to pin 4 to my light, and I'm going to say, be that low. Okay. So now I think we're ready to start our coding, which is always a fun, to start our simulation rather. We've done the coding. So are you ready to test it out? Sarah's got her fingers crossed, so we'll be fine. I'm just going to have a sip of water before we do. Now, I'm going to start the simulation, and then we will see. So when I start the simulation, if it's worked, nothing should happen because my button hasn't been pushed, so my light should be off. So fingers crossed, first step is see if the light stays off. We're going to start the simulation now. 3, 2, 1, go. All right. So you can see that it is running. My Arduino is plugged in, but nothing has happened. So now the moment of truth, if I press the button, is my light going to come on? Now, Tinkercad is really clever about how to simulate these things. So to press the button, you just have to click on it. So what I'm going to do, I'm going to bring it down and then zoom right in so that you can see that I'm pressing when I'm pressing the button, because you can see there's this little gray bit around the bottom when it's pushed up. And then when I click it, that bit will disappear. So if I go, and then my light should turn on, fingers crossed. So 3, 2, 1, click, and my light has gone on. Hooray! Have your lights gone on when you click the button? I've unclicked, and now I'm clicking again. Give me a thumbs up if your buttons are working. It's very satisfying. If it's not a problem. Often doesn't work first time. Pop something in the chat and we can check your code to see. Remember, it'd be really helpful if you can write what your Tinkercad login is in the chat so that Sarah can easily spot your code and find out. But while we're doing that, we can have a look at the most common mistakes. Now, one of the really common mistakes is people forget this wire here, the wire that connects it to the power. So double check that your wire, you've got a nice wire that goes from the plus line on your breadboard, the red one, all the way down to the bottom of the Arduino and to the 5 volts. And then check that you've got another wire that goes from that red line here. So you can see that my 2 red wires are connected because they've both got green circles on. Goes all the way up here, which then goes to the button up here. All right. So double check that. Fantastic. We've got a fixed circuit already. That's brilliant. And then some other things to check, again, like with all circuits, double check your connections are all right. So check that we've got from pin 2 up to our button, and make sure that that your the number of the pins that you're sending instructions to or that you are reading information from is the right one. So my button is connected to pin 2 here. You can see it's connected to pin 2 through my yellow wire. And my LED is connected to pin 4 through my green wire here. Okay. Well, some people have 2 buttons. You could totally have 2 buttons. Common thing with 2 buttons is probably, it could well be that Tinkercad is getting confused about, or the code is sending it to different buttons. Okay. So while you do that, do remember if you haven't, if it's not working, don't worry, because we've got the recording, so you can pause us. Make sure you've got to every step in the same way as before. And what we're going to do is we're going to create the circuit in real life. I'm going to turn on Arduino Cam in a second. Then we are going to send that instruction to our real Arduinos and turn our lights on. Okay? But if you're not there yet, don't worry. We can do this bit and then you can catch up with the recording or the worksheet that Dane sent around. Sorry, my brain entirely forgot the word for worksheet then. All right. So, great job, everyone. I'm going to turn Arduino Cam on. Right, so you can see Arduino Cam here. I've got my Arduino ready, just here, and I've got my breadboard next to it. So I'm all ready to go. And then here I've got all of the different components that I'm going to need. I'm really bad at knowing which direction to move my hand in to get the component in place. So a lot of you will have made the first part of the circuit last week, which is fantastic because it's just the LED. So it's just this bit. So you can just use the circuit, the same circuit as before, but I will do that bit pretty quickly. Right, so we've got these two bits, so I'm just going to do I'm going to do the first bit of the circuit. I'm going to make my light. So I'm going to take my light here like this, and I'm going to put it into my Arduino's breadboard like that. There you go. Then I'm going to take a green wire and connect my light to my LED to my Arduino. Right. Some of you are using your circuits from last time, which is very, very sensible. I pulled mine all apart, and so I've just got to redo it quickly, but that will only take me a minute. So I'm going to take my green wire, and it's gone from one of my LED legs to pin number 4. Now, you'll see that I'm having a bit of difficulty figuring out which is pin number 4. On the side of the Arduino, you can see that the numbers are on the side as well, and that's a bit easier to tell that you've got it in the right pin, right hole. So that's definitely in pin number 4. And I'm going to take my resistor and go from my LED here to the blue line, just like on my circuit, just like last week. Oh, some of you already made the real circuit. You are so far ahead of me. That's brilliant. And then the last bit of this first circuit, I'm going to go from the ground, the blue line here, to the ground. Like that. And I'm just going to check that it's in the right one. Yep, that's the right one. So I'm using the same colors of wire as on my Tinkercad. Except I've got an orange wire because I don't have any brown wires in real life today. But yeah, so that's one bit. Now the next bit is the new bit, the button. All right, so the buttons look like cute little bugs. Let me see. So there's a kind of silvery square with a round black circle on it. And then if I turn it the other way up, you can see it's got 4 cute little legs. Oh, and now it's trying to focus. There you go. 4 cute little legs. So I'm going to put that over the middle bit of my circuit. So, oh wait, if I do it this side, then you can see it a bit better. So over the breadboard, like that. So 2 of the legs are on this side of the breadboard, and 2 of the legs are on this side of the breadboard, and it covers the middle kind of channel, okay, that separates it out. Oh, you're all ahead of me. This is brilliant. I'm going to have to speed up, aren't I? All right. Don't worry if it is too fast, because we are recording this. So we've got the little button. Next, I'm going to connect my little button to pin number 2. So there, that's going into pin number 2 in the Arduino. And then it's connected to the little button over here, like that. And then I need the resistor to go from that same column to the ground, to the blue line. Oh, sorry, I'm moving things around a bit because it's a little bit fiddly. I have to do this. There you go. All right, just 2 more wires now. My first wire is going to go to the red line on my Arduino from the button. So I'm going to go from my button here, like this, to the red line. All right, and then the final one. Now I'm going to use a different color wire for this bit. I'm going to go from that red line to the 5 volts on the other side of the Arduino. Okay, over here. Like that. 5 volts. It says 5V or 5 volts. That's the wire that people most often forget, just in case you were wondering. All right. You are brilliant, everyone. So now we're just going to, I'm going to switch back to our shared screen so that we can transfer our code to the to our real Arduino. Okay, you all ready to do that? Give me a thumbs up. All right. Now, I'm going to remember, I'm going to stop the simulation to start with. Now, remember, if we want to transfer it to a real Arduino, we have to translate our blocks into a different coding language. So it's going to go from blocks to blocks plus text up here, like this. And then you see I've got this code in a different language. It says the same thing, but it's just in a different language that's easier for the computer to understand. So I'm going to highlight all of that, remembering all of the brackets, and copy that. And then I'm going to open the Duino.app. So I'm going to open a new tab and then say Duino.app, and I will pop that link in the chat. Yeah. Oh, but I've beaten to it. Thank you so much for your help, everybody. It's so great to have an army of helpers. All right, so we're on the Duino app, and then we click OK. It always tells us that things have changed. And we're going to do some coding. So we click on code here, and then we're going to create a new project. So I need to give it a name. I'm going to call it the same as my Tinkercad circuit, GYO 3 buttons, like that. And then I'm going to create. And then you'll remember, just like Tinkercad, it's like, oh, I know. Why don't you do this bit of code? That's not the code that we want to do. So we're going to highlight all of that and delete it. And then I'm going to do Control V to get my code from Tinkercad into my circuit, except I've copied the thing from the chat. So I'm going to undo that and recopy the bit from here. Silly me. Copy my code from Tinkercad and pop it in the Duino app. All right. Okay, you all ready? Now I'm going to, are we ready, Sarah?
Sorry, that was me keeping my fingers crossed because
Oh,
I never have any luck with Duino. I always get that 100% error.
yeah.
It requires so much patience. So I'm keeping my fingers crossed that we can all get our circuits working today.
Yeah, it does require a lot of patience, doesn't it? It really, really does. So I'm going to plug my cable into my Arduino, remembering we need to be really careful when we're dealing with electric components. So we don't touch the electric components, we don't move them while it is powered on. Okay, so I'm going to plug it in like this. Made a nice ding dong noise. And then if you can see my Arduino cam, you can see that the little lights are on my Arduino like that. Okay. Right. Now, how are we doing, everybody? Because I know that we've got some thumbs up, brilliant. Some of you were tweaking your code because you've done much fancier code than I have. So don't worry if you're not there, if you're not here yet, because we are recording this and you can always watch the recording. And we've got the troubleshooting session in just about 10 minutes as well, where we can help people one-to-one a bit more easily as well. So if you've got any questions, do pop them in the chat. If you're still making your circuits, that's completely fine. This is a really fiddly circuit. I find I'm really bad at buttons and I often squish its little legs and then I feel bad because I think they look like little bugs and then I feel like I've squished a bug's leg, which I haven't. So the important thing is just to be patient with it. And to make sure that all of your connections are in the right places. And actually, I think my connections are not in the right place. So I'm just going to fix that like that. Yep, I have my connection in the wrong hole. So always a good idea to double check your circuits if you can. And that's why making the different colors of wire really, really helps, because it means that it's easy for you to track what is going where. Okay. Right. So yeah, let's see. We've got our circuit from last time here with my LED. We've got the button. So yeah, don't worry if it's not ready yet. I'm just going to connect up my my Arduino and see if this works or if I need to go back and try it again. So I've got my code here in the Duino app, but it's not quite ready yet for me to for me to send it to the Arduino because I haven't selected the device. So I'm going to select device down here, the bottom right. And you can see that I've got a bunch of different things that are connected to my computer today. I have never seen the thing that says CDC abstract control model, so that's a new one on me. I'm going to try this one, the USB serial device, COM8, like this. And then, oh, there we go, COM8, and then I'm going to click connect. And you can see it has connected to something because at the bottom it says serial selected. All right, now we need all of our fingers crossed because we need to send it to the Arduino. So that is up here at the top, the one that looks like a play button on the top right. So I'm going to try sending mine to the Arduino, to the thing, and we will see if it works or not. Okay, so, or cross your fingers. Here we go. It's compiling. That means it's thinking about it. Uploading code, and it's done. So it's sent my code to the Arduino. Great step. Oh, and I can see some of you have got that 100% done as well. Brilliant job, everybody. And then I'm going to see if I have made my circuit right. Oh no. Let's see. Have I made my circuit right? All right, let's see. I'm going to stop sharing my screen so we can see if it works. And you can see on Arduino Cam, I've got my little button. I'm going to try pressing my button and then my light should turn on. Okay, so 3, 2, 1. Yay! All right, so I have a light turned on, which is fantastic. If you've got a light turned on, that is also brilliant. If you haven't got a light turned on, this isn't the first time I've made this circuit. Even today, I've already made it once and I got it, and it took me 3 times to get it right earlier. So don't worry at all if it didn't work first time. Or if you're getting 100% error, sending it to the Arduino. So for the last few minutes before I hand over to Dane, I thought it'd be helpful if we just remind everyone of a few quick troubleshooting things to do, particularly for those people who are joining us online. Now, firstly, with the Duino app, sometimes the Duino app gets really, really fussy and throws a bit of a temper tantrum at you. Particularly, it gets a bit grumpy when you unplug it and then plug it back in again. Often, the easiest thing to do in that case is just to close the browser and then reopen the browser, recopy it in, and reconnect it. That's often a really the easiest way of doing it. You can also try connecting your Arduino to a different USB port on your computer, because sometimes the computer just gets confused about where it's sending the instructions to. So that often helps as well, if you're just swapping them around. And also checking that the correct thing is connected to your Arduino. So if you click serial selected, you can see which one it is, which one it's connected to. And we had, for the first time last week, we had a really neat trick, which was to see if you could, if you open this and then if you unplug your Arduino, if one of them disappears from this list, that's likely to be the one that you should be clicking. It's a great, great tip, which we had never thought about, which I admit was a bit embarrassing after we'd done it.
This is the thing, isn't it, about troubleshooting? You don't always know solutions until you're in the moment. So
absolutely,
that's why it's so great to have this extra bit at the end of the session.
It really, really is.
But always sharing some of the ideas of almost an FAQ or an FATs, frequently asked troubles.
Yes. Always a great thing to have. So that is some tips for the Duino app. For the circuit, the most common thing is you've just put it in. You've just put a component in the wrong hole. So it's like one hole out, or if it's not quite in properly. So some of my wires are a little bit loose today. And the resistors in particular, they can be a bit hard to make sure that they are in properly. So make sure that all of your connections are in the right places and try tracing the circuits around. So follow the wire, follow the path of the electricity to make sure that you've got your complete circuit and all of the components are in the same places as they are in Tinkercad. But yes, brilliant job, everybody. Dane, I hope things are going well in the church. I will hand back. Oh, and I've just one final troubleshooting thing, because it's the one that I get wrong most of the time, is that your LED is the wrong way around. So you just have to try it the other way around. And that's the easiest way to do that. Just to pop it around the other way. Okay, I will hand over to you, Dane. I hope things are going well in the church for your concert. And we will say goodbye to the people online watching us the recording, but we will meet the rest of you for troubleshooting in a few minutes.
So thanks so much. This is looking great. I'm so pleased that we've got the button working.
Yeah, they've done so well, honestly. They were ahead of me half the time. It was great.
Yeah, so I think maybe we should get these people to take over at some point.
Yeah.
But as Sophie mentioned, there's always the recording, there's always the handout, the kind of worksheet to kind of follow through, and you can pause or fast forward the recording. And you can even have a play during, adding different sequences, adding different LEDs, more LEDs, seeing if you can experiment with other different bits and pieces, and you can always share with us your ideas next week. But this has been brilliant to see all the progress that people are making, building their physical circuits and experimenting with Tinkercad and the Arduino. But it's brilliant that Vicky's been with us, Sophie's been with us, Sarah's been with us, and all you guys watching online live. But we're going to stop the recording, but it's been so much fun. Thanks so much for coming, and we'll see you next week. Bye, everybody.
Thank you, everyone. Oh, well done.
Well done. Yay, one last one as well. Bye.
To finish the recording.
Right, we'll stop the recording then.